Hi, today I'm tailing the tale of my 200 horsepower Freelander conversion from this smoky old dog of a car into this. And the steps necessary to get there and make it reliable. You can see at the same time I've made it a bit more interesting by adding a lift kit, 40mm and some bigger tyres, rock sliders and so on. It's got a full custom exhaust and general fixes on it. On this video I'm just going to talk about the steps to make it a 200 horsepower turbo 1.8. It started off life as shown in this picture. It's only £400 bought on eBay. Previous seller wasn't particularly honest about the condition. He'd half started a turbo conversion, but the turbo wasn't plumbed in. It was blowing oil all over the place, which is why you can see all this smoke, and there was no exhaust fitted on either. So just for interest, I'm going to tell you about all the steps I went through to get it to be a fast and reliable motor. The first stage will be just talking about getting it running, and then what initial results I got from that, then doing it properly, rebuilding the engine and all those steps, which is the proper way to do it. So the first step to getting things put together was to put this exhaust system on. Just came with a lot of pipes and a lot of different bits. Most of it was from a Ford Focus ST, with some additional pipes that I had. As a sports cap, which comes from the Focus ST, flexi pipe. Fair bit of welding involved. Had to rejig the back box. That came from the same car. And the pipe going over the rear subframe needed a bit of sorting out, but that worked in the end. Starting from scratch from a standard 1.8 Freelander, you'll need the downpipe from a Rover 75 1.8 turbo, which has the correct fitting to bolt onto the turbo itself. I've got a separate video on MIG welding if you want to weld it up yourself. Here's the actual turbo now plumbed in. This is the oil drain point, goes to the block. It's now got the correct plumbing for the air going in and coming out. This one is an extra little water pump for cooling the turbo that I put on. Details of that I'm going to put in another video. Plumbing in the water feed to the turbo. Here the water should enter. This is the pipe. Don't have to have that additional water pump, but it does help. Otherwise the water should go from one of the feeds shown here, but T-junction here. That's the pipe that goes to the bottom of the radiator. Hard to see there, but maybe I can just point. Yeah, that one there just goes off to the radiator. That basically has a junction up the top there, which allows water to rise into the turbo. The output side for the water of the turbo is this metal pipe over here, just to be about 15 degrees or 20 degrees higher than the input side. So normal gravity would allow that water to rise through the turbo and keep it cool. And that pipe goes into this junction on the top here with this top coolant hose. So obviously you need a junction. So none of the air plumbing for the turbo was sorted. So this air inlet to the turbo, which is where my finger's pointing, conveniently, now this is the route I've taken, is to take it into the bottom of the air filter housing. And the old air filter inlet I've blocked off with a plastic cap. That's where it used to come from. And now the air inlet is here. So I've reversed the flow through the filter housing, cleaned it all out. If you use the smaller size 1.8 petrol air filter, that can go the normal way around, drop down inside. Then the air outlet for the turbo, which is this pipe coming up here, goes through these junctions, through into the front of the car. And I had to move the normal radiator further forward because you can see there's quite a tight gap between the front of the turbocharger and the fan for the radiator. So that's the gap with the radiator moved forward by about an inch. That was the original mounting hole for it. Drilled a new hole, one of those hole cutters that you use for reversing sensors. Had a couple of those in the garage, and just repositioned the plastic clip that mounts onto the top part of the radiator. Bottom part of the radiator can stay the same, and it just leans over, as I say, by about an inch. Just about clears it. You have to leave the intercooler loose and pointing down as much as it'll go. Then it just about clears the plastic in the bumper without any cutting of this Mark II bumper. And then this is where the intercooler output comes along, goes through a wide piece of, actually it was exhaust pipe, but stainless steel, 2.5 inches or something. And then I've reused some of the original trunking from on the inlet side, comes up here, goes into the inlet manifold. So originally it had a standard inlet manifold. This is an Mg6 turbo manifold I've changed it to. Came with this rather unusual ECU, completely disconnected. This is for controlling extra injectors on supercharged or turbocharged engines. So I thought I might as well use it. Has some quite useful things for use later on, that you can control the turbocharger boost levels. And it also has lots of different gauges for measuring air-fuel ratio, and it's got some rather crude logs for measuring the air-fuel ratio at different RPMs. So it's not something I'd recommend. I'm just showing you a bit of the history. This is actually the original throttle body, and just to get something running with that XIC extra injector controller ECU, I've actually put an extra injector on here. This comes from an old Chevy small block V8, quite a big injector. I've used the air inlet that normally connects to the idle air control stepper motor, which you can see I've relocated over here. I've plumbed in the fuel line for it, goes straight into some T-junctions on the fuel line. Fuel line's coming in at 3.5 bar, which is regulated by the in-tank regulator on a Freelander, so there's the right sort of pressure, and this injector is controlled by that XIC ECU. It ran okay. Extra fuel was being injected by an injector. Ran not very much boost, just for safety's sake, but it ran okay for a little while. The engine had a bit of a leak from the head gasket. I did retighten the head bolts down, but it was still a bit rattly from cold. Got it through the MOT test, but it didn't last long. A couple of days later, that rattle from the engine was basically symptomatic of a damaged piston, which is probably done by the use of this engine in a previous car from the previous owner. Basically, the piston melted, as you can see in this picture here, and the ringland basically of the piston had detached or melted, and molten aluminium was being blasted down on top of the conrod, made a bit of a mess, and it's pushing a lot of air and water into the crankcase, which was then pushing out into the rest of the air-filled system and out the exhaust. So that then takes us on to what are the necessary steps to do it all properly for converting a standard 1.8 engine into a turbo engine in a Freelander. So first, the engine had to be stripped down and rebuilt. I took the head off. Some of that detail can be shown in another video that I did on do's and don'ts of K-series rebuild. And not only was one of the pistons scrapped, it didn't have the shorter conrods that a turbo engine should have, which meant the compression ratio was too high, which is partly why the piston melted, but also the head had been skimmed too much. So the head was scrap. Unfortunately, I got another almost new head from eBay at a good price. You want to go for a set of these shorter conrods. I managed to pick this up second-hand from a guy on Facebook, actually. Very useful. Thank you, Pete. A set of the 160 turbo pistons, which are so slightly stronger. The height of the liners was checked, and extra shims were put on to give it a correct height and therefore sealing against the gasket. The ring gaps were set correctly for a turbo. You need to take the rings off the pistons, assemble them in the top, put them 20mm down in the liner, then with some feeler gauges measure the gap in between them. For a turbo engine, people have recommended 0.5mm for the top ring, 0.6 for the second ring down. While you've got the head off, you might want to consider porting the exhaust side. I noticed on the old head the exhaust ports were rounded off and opened out very slightly. So I've got an aluminium cutting bit, my electric drill, so it's quite a coarse tungsten carbide bit. What I did is make a little template piece of paper, stick it over the manifold, and cut around holes where the manifold gap is, and then you can line it up against your head. Mark with a felt tip pen where the excess metal needs to be removed. Just got going on like that. I'm not going to do anymore because it's all done. Obviously give it a good wash out, whatever method you decide to use, but make sure you haven't got any bits of metal in your cylinder head. And turn the can to open up the valves so you can wash any bits of metal out from under the valves if you've still got the valves installed. It's obviously better to do that without the valves in and the head stripped down. On the maximum gain from any porting, you'd sand with little sanding wheels and polish it off so it's very, very smooth, but I'm not after mega horsepower on this engine, so that'll do for me. So that was probably worth doing because I just measured the diameter of the standard exhaust manifold, which comes at 35mm, and now after a little bit of opening up of the ports, that exactly matches what we've now got on these slightly opened exhaust ports, whereas on the old one, even with the opening that some previous owner had done, they are about 34 or less, 33 maybe. So I might have gained a little bit, so worth doing. The inlet ports are not really worth doing because they're already exactly the same width as the inlet manifold at 34mm. On this slightly older style head, they're exactly circular, so 34 by 34. And notice on the later style heads, it's actually 34 by 32. A very slight flat edge at the bottom there, very slight D shape, which actually matches the inlet manifold. So these just being a little bit taller is not going to matter too much, I don't think. And there's certainly no improvement you can do with the standard inlet manifold. So that went on with a decent gasket, N-series gasket, already had the PRT thermostat. I put on the stronger oil rail onto it, new cam belt. If you've opened up the fuel rail and the fuel pipes and maybe you've got extra fittings on, it's a good idea to flush it out. Take this little cap off the end. This is the Mg6 fuel rail. Might have been used on the ZT turbo as well, I'm not sure. But it's got a little tight, car type valve on there. So get a little screwdriver, press that pin, and then a lot of fuel comes squirting out, so watch your eyes. But a rag over it and a pot underneath, and collect, I don't know, 100ml or something, just to flush out any contaminants before they get shot into the injectors. Because on the injectors you've got very, very small holes. I don't know whether you can see there or not, but there's about 4 holes on each injector. Don't want to block those. So that's the mechanical parts of the turbo engine reassembled. There's your turbo down there, just the standard GT 2052. So the input air to the engine is here, which is then very easy to pipe out to a cold air source, because we can go through that hole, maybe slightly widened up. Can't really see it there very well. A bit better with the flash on. But there's a hole just where the steering arm goes through. It's got to make sure the steering arm doesn't foul against it. Might have to cut a little bit of metal out to the left there. Take the pipe into the wing, probably go up inside the wing, and you could then either have a vent here high up, or you could have a snorkel as well going up the wing if you wanted. So here's a bit of 1 meter flexible pipe I got on eBay. That should be certainly wide enough. Opens out to 1 meter long. Really just started pulling it out, but quite firm. That should be good enough. This is the Mg6 manifold. Don't forget to have your one-way valve there, because you don't want to lose the turbo pressure by the air pushing out here going into your crankcase. So it stops air flowing that way. But it still allows it to draw in vapours when you close the throttle to empty the crankcase of vapours. The other crankcase breather, this one here, originally I did take it into a hole on the air filter housing, but when I was running it earlier and one of the pistons had a bit of a meltdown, then it was blowing out a lot of oily air and completely saturated both the air filter and the inside of the engine. So this time I've just routed it out to a separate filter over the top there. If that ever does go wrong again, I'd prefer it to make an oily mess around there rather than inside the engine where you can't see it. So the turbo and the manifold does get quite hot, so I have some sort of heat shield arrangement later to protect these pipes. On a short run it did smell a little bit rubbery hot. This one, as I say, has got the Mg6 inlet manifold with the metal fuel rail. Apparently it does have an inbuilt damper in it, according to what I've read, although it's not obvious seeing it. And at the moment I've just got it fed with the constant 3.5 bar coming from the fuel pump on the Freelander, but a gauge on it as well with a few T-junctions, some AN6 and various T-junction fittings. And that confirms I've got about 3.5 bar, about 50 psi. What I'm going to do later is put on one of these electronic pressure gauges. This is a sensor for oil pressure and came with a kit of gauges like these. So I'm going to use this gauge, which I say normally reads oil, but it's a similar pressure range for the fuel rail pressure, 3.5 bar, and I'll have a switch so I can switch between measuring the fuel pressure and measuring the oil pressure. The temperature gauge on here comes with and this kit comes with a little sensor. I'm going to screw in to this pipe, which is the output from the intercooler, which is after the output from the turbo, just to check on intake air temperatures, because I don't want to get in too hot, melting a piston and so on. You might wonder what this little arrangement is. For a little while before the problem with the engine, I was running on this XIC model 1000 injector control unit. It's quite a simple additional ECU. It only controls the fueling for extra injectors. That's what the X in XIC stands for. So to get it simply running initially, I had this extra injector, which I strapped onto where the idle air control valve normally goes. The idle air control valve I plumbed into the lower pipe. So this is a standard throttle body. And that lower input pipe to the throttle body is normally used for the crankcase breather output, which, as we discussed earlier, I've taken off to an external filter. So this extra injector was plumbed into the 3.5 bar fuel rail pressure. Make sure if you do that, obviously you need high pressure pipe, 20 bar pipe that is. It seemed to work quite well. Not something I'd recommend, because as I say, the XIC is quite a simple controller. It doesn't have too many positions on the map for RPM versus map versus fueling, and doesn't control the ignition. So I've now changed over, paid KMaps for a remapped ECU. Sent them the original Freelander ECU. They remapped it, KMaps symbol down there. That's running nicely at the moment. Had a quick drive around the block, that seems fine. What I've got to do now is up the turbo pressure to 11 psi, because it's running with no control to our turbo solenoid, so nothing wired in. The plumbing is wired in, so effectively the turbo output, that pipe there, goes onto the turbo actuator, which you might be able to see down there. Zoom in. Which is that pipe there, going to the bottom of that actuator, that circular thing where my finger is. That's the thing that pushes the rod out onto the wastegate of the turbo. And what I'm also going to do now is wire up the turbo control solenoid into the turbo boost controller solenoid output of the XIC. So some of the reason I've still left it on there is it does have a simple boost controller function. Just has a variable pulse width modulated output. So for instance, if you modulate it at 50% pulse width modulated square wave signal, then effectively half of the pressure of the turbo is getting to the actuator, which means it'll go up to twice the boost pressure before the wastegate is activated and it's cut off. So whereas before the standard pressure is about 6 psi, that would take it up to 12 psi. I actually want to take it to just 11 psi. So I've got a boost gauge, not a terribly accurate one because it's that right hand one, can't see it at the moment. But it is a cheap one from eBay/China. But the XIC also has an inbuilt manifold pressure sensor, so and that seems to be, I think, a little bit more accurate. So I can double check the value and read off that value as well to make sure that it is only 11 psi. The other thing I quite fancy doing is blanking off the recirculate valve on the turbo. So this is a blank plate I got on eBay, quite cheap. This is a generic blow-off valve. So I guess because I'm a bit of a child at heart, I fancied that whoosh sound in between gears as the blow-off valve releases pressure from the turbo. And I'm just in the process of testing it here actually. So I just wanted to see what pressure it actually releases at. So there's a piston here. This goes to the engine side of the inlet manifold, the high vacuum area. So when you take your foot off the throttle, this goes to high vacuum, pulls up on the piston, and also any pressure that is on the boost side of the turbo will also be pushing on the piston, and the pressure difference will open the piston and release it out of either side. This was quite cheap, and I've wired up to my tyre pressure gauge with an accurate gauge on it, and you can probably hear it. Yeah, just a little pop there as it reaches about 11 psi, and yeah, you can actually hear it hissing. I release the pressure a little bit. Yeah, at about 11.5 is where it blocks off. So that's good enough. So I want 11 psi, but don't forget, of course, it's the pressure difference between the two that is the 11 psi at which it goes off. So when you're decelerating and the throttle is closed, probably get about minus 20 psi here compared to something like atmospheric pressure. Very little boost on the other side. So this is actually going to be opening, which is a slight disadvantage because it's going to be opening, and effectively the inlet side of your engine could be sucking in air through your blow-off valve, and of course it's unfiltered. So eventually I think I'll put some filters on this as well. This is the original 1.8 trunking, which had this convenient bit of pipe on the side. Cut it off with a scalpel, and then that makes a convenient position to fit our blow-off valve. Don't forget to fit this vacuum line into your manifold, which activates the blow-off valve. Or if you stick with the original recirculating valve down on the turbo, there's a little nipple in that position that needs that pipe connected to it. As there's a fair bit of heat that comes off the turbo and manifold, and these hoses are close by, I've used the original heat shield, cut it down a little bit, mounted a spare piece of metal I found in the garage on it, and I'm just going to slot that in between the hot part of the turbo, something like that, and the pipes to provide a bit of insulation, and I'm just going to attach it to that alternator mounting nut. That should keep some of the heat away from the pipes, but also with a little gap, let some of the heat out as well. Just a quick note on the oil supply to the turbo. So I've disconnected the lower connection. So this is the output oil flow from the turbo. Goes on to a position on the engine block over here. Actually, a previous owner, not quite sure why, but put this block on here, mounted on it first. Obviously, you've got to drill through the actual block to return the oil back to the sump. And because of that block that was on there, the pipe that's originally used for the turbo oil supply has been shortened a little bit. But this pipe is very, very thick and difficult to bend. And as a result, these connections were under quite a lot of strain and didn't actually seal very well. So I'm going to change the pipe on there to something more suitable. There was a bit of heat shielding stuff, a bit old, that was around it as well. So I'll see what I can do to make that a little bit better. The feed to the turbo, the oil feed, is a pipe that goes on top and connects over to the top of the housing for the oil filter, which is here. Now, I think this is probably the original housing. What is a lot easier is just to buy the turbo engine oil housing. Then you'll have a connection on the top for the oil feed. If we can get in there, you can just about see, yeah, that pipe in the middle of the screen there. Again, previous owner has probably drilled and tapped an oil feed to it. At some point, I'll probably change the housing to a proper turbo one. The position of the pipe is a little bit weird. I'm pretty sure that those mounts on the pipe should bolt onto those spots on the engine block, but it seems to work for the moment, so not too bothered about it. While this lower pipe was off, I just checked that we had the right amount of oil feed through the turbo. You don't want too much, so it starves the rest of the engine, but you want sufficient so that the bearing of the turbo is well lubricated. And as we can see here, start the engine for a second or two, you see a small flow of oil coming out of the turbo. The output side's low pressure, so we don't need to worry about the pressure capability of the pipe. Just make sure we've got a good seal. That's it with our pipe fitted. It's only a temporary one, and I haven't got any heat insulation fitted over it at the moment. What you've got to be careful of on rubber hoses is there's a lot of different specifications. So you want one that's oil tolerant, and preferably the highest temperature you can get as well. So neither of those things this one is, so it's just a temporary fitment until a new part arrives, so just be careful of that. Check it out for leaks before you fit heat insulation, just to make sure everything's okay. So this time I didn't use the XIC ECU for injection. I went and got a proper KMaps ECU with a 200 horsepower map. Changed over the manifold to a turbo manifold. If like me you use the Mg6 one, it doesn't have a space for the idle air control stepper motor, so I had to drill and tap a position for that, resealed it around it, and kept with the original throttle body. The idle air control now goes into the tube that was for crankcase breathing. Left the injector on there just because I never got around to removing it. You never know, might want some extra fuel. It doesn't actually do anything. It's not being used or activated by the ECU. I did put a few junctions on the fuel line coming in, and initially I put a gauge on, and now I've put an electronic sensor on for measuring the fuel pressure, because I wanted to make sure the fuel pressure wasn't dropping when it was on full boost. And fuel acceleration, just to see if I needed to upgrade the fuel tank pump. And so far I can only see a very slight drop in fuel pressure, so there's not an urgent need to upgrade that pump. Plus also the air fuel ratio stays at about 11, which is what it's designed for. So here's the turbo engine running up, running nice and smoothly. So that's it. It's certainly made the car a lot more interesting, a lot more fun to drive, and a lot faster. So good luck with yours, and thanks for watching. Bye.